Hi, so this is the first in a series of videos I'll be doing covering my usage of the DeepMind control suite. I'm over at the archive page, and I guess in their own words, the DeepMind control suite is a set of continuous control tasks with a standardized structure and interpretable rewards intended to serve as performance benchmarks for reinforcement learning agents, and the tasks are written in Python and powered by the MuJoCo physics engine. So I'm making a huge assumption here that anyone watching this has already read the paper. I think the paper gives a really good overview of, I guess, the design decisions and also, I guess, the general structure of the API and allows you to kind of understand it in a little bit more detail than if you were to just dive in. Great. So associated with the paper is this repository on GitHub called DM Control. And this is what I'm using as a foundation for everything I do. And in fact, I guess this encompasses the whole package. So what I'll do through this video is essentially go through, I guess, installation and setting up, and then get to a point where I actually have one of the, I guess, tasks running already. So if we go ahead and follow the instructions in the README for the repository, we can actually see that the first thing that we need to do is install MuJoCo, which is the physics engine. And specifically, we need to install MuJoCo Pro. We have to extract it at this directory here. And so yeah, let's just go through the first step. So I head over to MuJoCo, click download, and it tells us here that we actually need an activation key. So MuJoCo Pro isn't exactly cheap, but fortunately, they have a 30-day trial license. So in order for you to get one of those, you just need to fill out this form right here. So I've already done that. And there's also this this little utility here that you need to use in order to obtain your computer ID. One little, I guess, pitfall you might have if you're not familiar with, I guess, using Linux machines, for example, is you'd have to run something like this in order for you to be able to run the file or to run the executable, and then you'll be able to get the ID, and that's it. So within a couple of seconds, you'll get an email, and it will have the license text. And yeah, we'll need this license text in order to be able to use it. So go ahead and download one of these, and I've already done that, and I've followed, I guess, the instructions in the README to extract it to this particular directory. So if I head over to my terminal, and I just change directory to that directory, then you can see that I have it here. And I also have the license key already in place, right? So this is what's available in that email from MuJoCo. So the first thing I'd like to do is just to give you kind of a way for you to almost like a sanity check once you've installed MuJoCo. So if you head over to the website and check out the documentation, on programming, you'll see that there's actually an instruction for when you're getting started, you can immediately run a simulation. So I'm on Linux, so I'm going to go ahead and run this command. And I will do so from the bin directory, as it says here. And we'll see what the results of that are. So if I go ahead and run that, we will see that, yeah, we essentially have a simulation already running. And in this particular instance, there's nothing fancy happening. The initial conditions are always the same. So this is just an example that comes with MuJoCo. And MuJoCo is actually really interesting. It gives you like a way to declaratively kind of state what models you want. And then it will just do all the kind of physics. So you use XML in order to specify your models. And this is one of the models. So I'm going to go ahead and cancel that. So the next step now is for us to actually clone this repository. So that's just as simple as git clone. and you just use this URL here, and I've already done that, right? So, and this is in order for us to kind of meet this requirement here. So we need to install this Python package, and you can either run it directly by going towards like kind of pip installing against the Git repository that's remote, or you can clone the repository and you can run pip install against the path of the DM control, and that's what I'm doing, right? So I've already cloned that, and if I head over to Sublime Text here, you can see that I've already got it, right? So this is just the repository as it would be. So I'm gonna change directory to where that is, and it's actually in my downloads, DM control. And if we do git status, yep, that's what I'm using. Great. So now I need to run sudo pip install, and I'm going to pip install from right here. And yeah, essentially I've just installed DM control, so that means now I'm able to actually access it, right? Great. So this should really be number 2, because in order for you to actually get anything done, actually no, it doesn't matter. Like, this happens at runtime. We need the MJ key at runtime, and I think I already showed earlier that I've moved my key to this location that it is expected to be. Great, so everything is ready, and now we need to just get some additional dependencies depending on what we're using. So I'm on Linux, and this is the instructions that they give you in order for you to get libgl fw and libglew. Unfortunately, these haven't worked for me, but I've come up with some that do. So when I run this, and I can just show you, then it actually does work for me. Whereas if I was to run the command that they provided, for some reason or another, I'm not able to actually download that. You can see that I couldn't find those packages. And this is something that I found out from doing a little bit of research, right? Great, so I have all the dependencies that have been stated, so I should be good to go, right? So in the README, they actually provide a quick start where you essentially load DM control. Well, from DM control, you can import the suite. The suite has a method called load, which allows you to essentially load one of the tasks. Here's, I guess, an example of iterating through every single one of the benchmarking tasks. So this is just a dictionary, and you just loop through it. But we're not going to do that. We're just going to do it on specifically one task for the purposes of just showing how to get one particular task working end to end. So when you do have a task, you can step through a particular episode and print out reward, discount, and observation by doing this. So all that's happening is we have a task already in place. We grab the action spec, which is essentially kind of like the format that this particular task expects actions to be in, right? So you have to conform to this spec. And we reset the time, and we get the time step, and then now we can essentially, well, the time step just gives you a bit of information. So time step is where you actually get the observations, a discount, the reward. That's where all the information is for any particular time step. But it also has a convenience method called last. And what that does is it tells you whether or not you've reached the end of the simulation. So let's have a look. What's happening here? So we're looping through. Before you get to the last step, what we do is we generate an action using just a NumPy, a random NumPy array, I guess, or matrix. And we use the action spec shape in order to generate that, right? And then we create a new, well, we essentially move forward in terms of like the time step by issuing an action, and that action gets applied. And I guess all the bindings to MuJoCo make it so that that action is actually applied on the model. And then you just keep doing that. So this is essentially you iterating through issuing an action, seeing what the response is, and then issuing another action. So you can imagine that you would have some kind of like I don't know, some reinforcement learning agent in place that takes the observations and generates new actions. But in this particular instance, the actions are just completely random. So we're going to actually go through that. And that's like before we actually head over to the example. At the very end, there's an illustration video, and I thought this was really cool because it shows you the model actually, I guess, being controlled, right? Because it's always nice to see something visual. So I think if we edge towards here, we can actually see the humanoid ones, and these are really cool because like you can tell that now it's actually able to stand. I don't know by what means. Well, it's been reinforcement learning agents are what's responsible for all this. Great. So now what we're going to try and do is actually see this live. So if we head over to Sublime Text, we will see that I put together an example.py. It's very similar to the one that's provided in the README. I'm grabbing specifically the humanoid run task, and I'm just doing exactly the same stuff as before, right? Initially, I'm grabbing the action spec. I reset the time step as before, and I just have a counter here. And I'm using that, I guess, as part of my condition so that I only have 500 time steps before I stop. The humanoid run task is essentially one that could run forever. So I want some means of being able to stop. I go through the same process as before. I'm just using the random actions. I added something interesting here where we're able to essentially render a particular moment, a particular step. I get the data from that, and then I actually create an image. I save that image, and then I proceed, and eventually this comes to a stop. I then take every single one of the images that I generated because I'm saving them to this frames folder, and I generate a video from that. And yeah, I think that should be pretty cool. So this is code that anybody can run once they've gone through the steps that I mentioned before, and you can essentially see a video of your particular simulation, which I think is pretty cool. This part here is just responsible for resetting the frames folder. So I'm just making some calls like rmrf to get rid of the folder and then remaking the folder. Great, so if we go back to bash, let's see where we are. So everything's actually in this subfolder called DM control, and if we list that, we'll see that we've got my example.py here, and literally it is as simple as running python example.py. But before I run that, I just want to go back to the Sublime Text example.py and mention that I brought in a bunch of dependencies that weren't there initially, right? So on the README online for DM control, there's only this line. That's not actually right because you need NumPy as well. So I've added that because right over here when we're generating the random action, we're using NumPy. I'm also introducing Pillow here. So you can actually just install Pillow by running pip install Pillow, and that allows me to create the images. I also install ffmpeg, which is this bit of software that allows you to essentially create videos. And this is the same as me just running this in command line, except I'm doing it from Python because it's easier. So yeah, I'm going to go ahead and run this, and we can see what the result is. Okay, so that was not the right syntax. So it's actually Python example.py. And yeah, we can wait for it. So essentially what's happening right now is you can see that I print reward, discount, and observation. And if we go back, we can see that what's being printed out is like joint angles, com velocity, torso velocity, all this sort of stuff, right? So this is just information at every single time step. And you can dig deeper into it if you want to, but the option is there. And that's what's really great about the API. It gives you all the information that you need. So we'll just wait for this a little bit. It'll be very fast. I think probably in the end, we're just going to generate a video that's like maybe 10 seconds long. So yeah, just bear with me. Yeah, so in the upcoming videos, the plan is essentially to get a reinforcement learning agent working with my setup, and to demonstrate how you can actually go end to end with an actual reinforcement learning agent. So yeah, we reached the very end, and right there is where we reach, I guess, the 500th time step, and then FFmpeg gets kicked off, and what it does is it essentially goes through every single one of the images that has been generated, and we can see that like where the images are by going into the frames folder. So you can actually see that here are all the frames that are generated using Pillow, and if I just step through them, there you go. So finally, let's have a look at the video that was generated. So there we go. This is all just completely random action, and hopefully by the time that I actually get to the later videos, we'll be able to essentially replicate what was shown in the DeepMind video, right? We can have a reinforcement learning agent actually walking, running, etc. So I'm looking forward to that. Great, thanks.